All right, so I want you guys to start off doing the exploration. So you're doing parts A all the way through D. Okay, A all the way through D together with your groups. Go ahead. Okay, let's go ahead and look here. So A says write a formula for the area of the parallelogram. Okay, so we know that area equals base times height. Okay, so area equals base times height. B tells me to go ahead and substitute in the values that are given. Okay, so I'm trying to find area. My base is, let's see, my base would be this part right here, right? Or this part right here. Either one. Oh no, sorry. That says area equals 30 inches. Okay, so we don't know the base, right? But we do know the area. Let me back up here. Sorry, I didn't read very well before I started. Okay, so the area is 30 because it tells me that. I don't know my base, but I do know my height is 5. Okay, so in order to get rid of that 5, I'm just going to divide on both sides, and I end up with B equals 6. So it looks like the base equals 6 inches. Okay, so the base equals 6 inches. Okay, let's go ahead and look at C. C says solve the formula in part A for B without first substituting values in. So just like what we looked at on warm-up, we have area equals base times height. Okay. So in order to get rid of the H, we want to divide by H. And we end up with B equals area over height. Okay, so the base is going to equal the area divided by the height. Then it says, compare how you solved the equations in part B and C. How are the process similar? How are they different? What'd you guys come up with here? Yeah.
They're the exact same, except for one is letters, one is numbers.
Good. So they are the exact same, except for one is letters, one is numbers. So with a literal equation, okay, these are called literal equations. With a literal equation like this, when we are solving an equation with multiple variables for a single variable, we want to basically treat all of the variables just like numbers. Okay? Whatever opposite operations we would do to get rid of those numbers, now we're going to do those same opposite operations to get rid of the variables that we don't need. Okay? Alright, let's look at page 2. Okay. So let's look here. So core concept, let's just look at a couple of them together. So we want to make sure, guys, that we are always solving for the piece that they ask us to solve for. Don't always assume it's X or always assume it's Y. You always have to pay attention for what it's asking you to solve for. So on number 1, it's clearly asking us to solve for Y. So I'm just going to, since we're in the beginning stages here, I'm just going to highlight what I'm trying to solve for. Okay, so that Y right there is the only piece I want to keep on that side. So what do I need to get rid of? Yeah, X. I need to get rid of X. So my opposite operation to get rid of X would just be subtract it, right? Because it's positive. So I subtract over to this side. Okay. The weird part about literal equations is rarely you have like terms that you can combine. So it looks messy, but it's right. I promise you. Okay. So I have Y left on the left-hand side. Do I have any like terms on the right-hand side? No. Read me what you see on the right-hand side. What do you see on the right-hand side? What? 7 what? I can't hear you. 7 divided by negative X. Are we actually dividing? Did we show a division there? It's subtraction, right? So we see 7 what? Minus X. That's literally what you write down. You write down 7. What just happened? Oh, goodness. All right. 7 minus X. Y is by itself, so I'm done. Seems strange, but it's right. Okay. All right, let's look at number 2. Okay, so I have X minus Y equals 5. So I'm trying to solve for Y. Am I trying to solve for y or negative y?
Negative variable.
Does it say solve for negative y?
No.
It says solve for y. Okay, so that's going to be important a little bit later. Okay, so I first need to get rid of x. Is x positive or negative? It's positive. Don't let that minus sign afterward confuse you. So since it's positive, I'm going to subtract it over. I am still left with negative y. On the right-hand side, again, those are not like terms, so it's just 5 minus x. Negative y, that's like negative 1y, right? I can put my imaginary 1 in here. So in order to get rid of that negative 1, I just need to divide by it just like it was any other number. So I'm going to divide that whole thing by negative 1. So I'm left with y equals, and dividing by a negative 1 simply just flips the signs of everything. So since it's positive 5 in the original, now it's going to be negative 5. Since it's minus x in the original, now it's going to be plus x. Okay, so that was a two-stepper there. Okay, 3 and 4 are pretty quick, so let's do those really quick. I'm trying to solve for a, so I need to get rid of b. AB, is that multiplication, division, addition, subtraction? What is that? It's multiplication, right? So I want to get rid of b. So I'm going to divide by b. That's gone. I'm left with a equals 2 over b. Excuse me. Sorry, got something caught in my throat this morning. Okay, let's look at number 4. Okay. I have a over b, that's division, right? So I want to get a all by itself. So I am simply going to multiply by b on both sides. Okay, that cancels my b's. I'm left with a equals 10b. Okay. All right. Let's do some practice problems here. Let's try... Oh goodness, there's lots of them. Let's try. Actually, you know what? I feel like I should probably do one of these with you guys. Yeah, let's do 3 together, and then I'll let you guys do the 3. Try these problems, okay? Because this one's a little more advanced than the one that we were doing before. Okay, just slightly. Okay, so we're trying to get y by itself. Okay, so trying to get this y all by itself. So what do you guys think should be my first piece to get rid of? So we have either the 2x or the negative 4. Generally, do we get rid of addition subtraction first or multiplication division first? Talk to me, guys. We usually get rid of multiplication division first. It would be the opposite of PEMDAS, right? If you're doing opposite operations, you got to start at the bottom of PEMDAS and work your way up. So I want to get rid of the addition and subtraction first, okay? So since I have a positive 2x, I want to get rid of it by subtracting 2x from both sides. Okay, so that's gone. I'm still left with negative 4y. Are 12 and 2x like terms? No, because one's a regular number, one has an x. So 12 minus 2x. Okay, and then I need to divide by negative 4 on every single piece. Okay, remember addition and subtraction just happens one time on each side. When you multiply or divide, it has to happen to every single piece on both sides of the equal sign. Okay, so that's all gone. I'm left with y equals 12 divided by negative 4. So 12 divided by negative 4 is negative 3. Okay, I have negative 2x divided by negative 4. Okay, can I reduce negative 2 over negative 4? What's a negative divided by a negative? Positive, so those go away, and it's plus 2 over 4. What does 2 over 4 reduce to? 1/2. So I have 1/2 x. I just like to plop the x out beside the fraction rather than keeping it in the top. Okay. So I have negative 3 plus 1/2 x. Okay, can I get a comfort level of how you're feeling right now with literal equations? So that's a 3, 2, 1, 0. So 3 is mastery, 2 is near mastery. 1 finger is needs improvement. Okay. 2s are a good place to be right now. Okay. See a couple 1s, and there's no problem with that. This is a tough concept. All right, let's go ahead and do the 3 try these, please. 3 try these. So you're doing 4, 5, and 6 together with your groups. Go ahead. Okay, so let's look at number 4. Okay. So I just want to reiterate, always do opposite operations in reverse order of PEMDAS, right? So addition and subtraction is at the end of PEMDAS. That's what I would want to do first when I'm solving opposite operations. So if I'm trying, if I'm trying to get y all by itself, okay, I want to get rid of the addition and subtraction part first. So the thing being added to y is 4x, so I want to get rid of that first. So I'm going to subtract 4x since it's positive. Okay, so I have y equals 2 and 4x are not like terms, so I just have 2 minus 4x. Okay, and that's it for that one. Number 5 has an extra step on there, so I want to solve for g. Okay, so I can see on number 5, just to kind of talk us through this, I can see that negative 4 is being multiplied by g, and I can see that 8 is being added to g. So I was wanting to get rid of the addition and subtraction first. So subtract 8 from both sides. So I have negative 4g left equals 3h minus 8. And again, those are not like terms, so I have to write what I see, 3h minus 8. Okay, now my last step to get g by itself, since that's negative 4 times g, is divide by negative 4 on every piece. Okay, I have g equals 3 divided by negative 4 is negative 3/4 h. And then negative 8 divided by negative 4 is positive 2. Okay, any questions there? All right, lastly, number 6. Okay, we have solving for y. Okay, so I want to get rid of that x. Oops, clicked the wrong button. Okay, I want to get rid of that x term first. So since it's negative, I'm going to add it. So I have 9y equals 9 plus 3x, since they are not like terms. Okay, my second opposite operation to get rid of that 9 is divide by 9 on every piece. So I have y equals 9 divided by 9 is 1. 3 divided by 9, I can reduce that by 3 on top and bottom to get 1 over 3. So plus 1 over 3x. Okay, any questions so far? All right, let's look at our back page. Okay, so application type stuff, okay? So let's look at number 13, and this was kind of sort of what we were getting at on warm-up, okay? So it says, it gives me the area of the triangle. I want to solve that formula for b, okay? So if I'm getting b by itself, how do I get rid of a 1/2? Multiply by 2, right? So I want to multiply by 2 first. On both sides. So I have 2a equals, that's gone now, bh. Okay, and then my last step to get b by itself will just be divide by h. So I have b equals 2a over h. Okay, so now I've solved it for b. Let me zoom back out here. It says, if the height of the triangle is 6 centimeters and the area of the triangle is 33 centimeters, what's the measurement of the base? Okay, so that's perfect. Our formula is solved for the correct thing because we're trying to find the base. All I need to do is plug in 6 for the height and 33 for the area. Okay, so b equals 2 times the area, which we know the area is 33, over the height, which we know is 6. Okay, so now no more algebra needed. We just need to simply Simplify. Haha. Okay, so 2 times 33 would be 66. And then 66 divided by 6 would just be 11. So the base equals 11 centimeters. Okay, any questions? All right, let's do 16, okay? Let's try these number 16. Go ahead and do that together with your groups. Go ahead. Okay, guys, let's go ahead and solve for W. So if I'm trying to solve for W, I first want to get rid of that 2L term. Okay, so I'm going to subtract off 2L from both sides. Okay, so on the left-hand side, P and L are not like terms, so I have P minus 2L. Those are gone, equals 2W. Okay, and then my last step to get W by itself is divide by 2 on every piece. Okay, P over 2 is not going to reduce, so I'm going to leave that alone. P over 2 minus, the 2's are going to cancel, I'm just going to be left with minus L. And then the 2's are going to cancel on the right, and I'm going to be left with W. So W equals P over 2 minus L. Okay, so they're solving for W. Now let's look at the information it gives us. So it tells us the perimeter is 16 and the length is 5. Okay, so I have perimeter equals 16. So I'm going to do W equals, I'm just going to bring the W over to that side. So perimeter is 16 over 2 minus the length, which is 5. And then I'll get the width. Okay, so let's go ahead and solve that. So 16 over 2 is 8, and then 8 minus 5 is 3. So the W, the width, is 3 meters. Okay, so I know in the immediate, if we're just solving for one, piece of information, generally it's not easier or harder to go either direction, to just plug the numbers in and solve, or to solve and then plug the numbers in. It's not really easier or harder either way. But like I showed you up on warm-up, if we have some kind of table of data and we want to find various radii, I think that's the right word, for a number of circles where we have the area, then that's going to be useful for us to have that formula solved for the specific piece we need. Okay?